This conference is brought to you by CallStack, a total software engineering consultancy.
Big round of applause, let's go.
Hello. Hi everyone. My name is Alex, and I'm a software engineer on the React team at Meta. Today, we're going to take a look at what we've been building with React Native's Debugger in the last year. A little bit about me. I've been part of the React team for 2 years. I'm based in London, and before joining React, I worked in industry, building web services and mobile apps, and began using React Native in 2016. And this is my 4th time here in Wrocław. To now be directly involved with this team and this community, and to improve our technologies, means so much to me. It's a dream, and the last 2 years have been truly incredible. I work with the awesome and talented team looking after developer experience. We focus on the tooling that enables developers to confidently iterate on their apps using JavaScript and React. This includes taking more recent ownership of debugging and the React DevTools browser extension. Today, we're going to explore what's new with the debugger. But before we do that, I'd like to take a look at where we came from. So let's explore the question, what is React Native? React Native is a toolkit for writing native apps using JavaScript and React. It's a lot like a browser, but better. It's cross-platform, but can look and feel native on every platform. You can add your own native code or download libraries to do things that are hard or even impossible on the web. For those reasons, React Native isn't a browser, but it's also not a browser. React Native has always been inspired by the web, especially when it comes to the APIs, programming model, and the tools you can use to build your apps. Our philosophy is that your knowledge of JavaScript and React should help you build high-quality experiences for any platform. And back at React Conf earlier this year, we recommitted to this strategy by announcing future changes in React Native's core APIs to gradually align with the web. This is a direction we're excited about, and one we're implementing across the team. A big part of building high-quality experiences is being able to debug, inspect, and measure the performance of your app. This is something that browser vendors understand, which is why every modern browser comes with a suite of developer tools built in. A JavaScript debugger, allowing step-through understanding of code. A console, allowing you to view and filter app logs and run interactive statements. An element inspector, a performance profiler, and much more. These are mature, feature-rich development tools that provide best-in-class usability. Good developer tools support high-quality experiences. And the React team has understood this from the beginning, which is why we built React DevTools all the way back in 2014. That's right, React DevTools is older than the spread operator. As a browser extension on web, this provides developers with a components inspector for viewing and interacting with the React element tree, and a profiler to understand performance bottlenecks in your React code. The idea of being able to look under the hood of your app to understand it better and fix issues isn't new. But as React Native evolved over the years, particularly with innovations like the Hermes engine and new synchronous architecture, debugging gradually became harder instead of easier. So what were our options? 9 years ago, React Native launched with JSC debugging via Safari, which worked well, but supports only Apple's JavaScript core engine on iOS, which we've since moved away from. Then, we introduced Remote.js debugging. This supported both platforms and used Chrome as a front end. However, instead of communicating with the JS runtime on the device, app code would instead be run off-device in V8. This separate execution context offered some compatibility with web tooling, but at the cost of inconsistency with how your code would execute in production. Next, we had direct Hermes debugging, using Chrome to communicate with the instance of Hermes on the device. This approach, as with Remote.js debugging, required a number of hacks. In React Native 74, we made incremental improvements to Debugger and Hermes, as well as adding a one-click launch flow. We also launched Flipper back in React Native 62. Flipper aimed to provide React Native developers with an extendable debugger host that also integrated native debugging plugins. While Flipper had some initial traction, it added complexity on top of direct Hermes debugging, and neither the Flipper nor React team were able to specifically invest further in Flipper for React Native. Over time, our integration became more unreliable, and we announced its deprecation last year. Really, this was a huge mess, which was reflected in our documentation and justified user confusion. We also supported additional in-app developer tools, such as the Inspector panel, Logbox, and Performance Overlay, all of which overlap with browser DevTools capabilities. Some of these tools have been better maintained than others. In short, tooling was fragmented, and due to lack of maintenance, debugging was hard and unreliable. By the time we formed the developer experience team at the end of 2022, it was clear that we needed to make the tools for debugging React apps more powerful and much easier to use. But we got the browser DevTools bit right. Each of the debugger solutions before used a browser debugging protocol to power their core JavaScript features. The rich functionality offered by browsers, and specifically Chrome DevTools, is familiar to web developers and ideal for the concerns of a typical React app. And in fact, several more debugging features from the browser fit our programming model. These present core application concerns that are common with React on web. Each of these are a valid conceptual fit with what React Native does today. We understood this vision last year when we announced we were all in on CDP, the Chrome DevTools protocol. Building on CDP would enable us to use a single communication protocol for all debugger interactions, and it provides a complete model to implement JavaScript and web-like debugging features. Our conviction in CDP is based on some guiding principles. Familiarity. We believe that the tools you use to develop React apps should be the same across platforms. If you want to start being productive with React on a new platform, you should be able to get started with the tools you already know. Cohesion. On the web, if you want to debug or inspect anything in your app, you know where to start, the browser DevTools. There should be a similar, familiar, universal entry point for debugging React Native apps. Simplicity. It's better to have a tool that does a few things well than many things poorly. Native platform tools, like those in Xcode and Android Studio, absolutely have their place for debugging and tracing native code. These are things you might occasionally want to do when developing a React Native app. The job of React's built-in tools is to work alongside the platform's tools, not replace them. We believe this is also the correct scope for the tools that we include with React Native. This keeps us focused on the problem space we can uniquely solve and maintain over time. This comes back to us being all in on CDP. Since CDP is a mature protocol, it's become supported by multiple front ends, which support some or all of the debugging features available in browsers. Making CDP the architecture for React Native, and doing this well, would enable us to support specialized user entry points in future. So in a way, we were here last year, actually during the keynote at this conference, when we first shared this refocused journey. We started defragmenting our tools. We experimentally shipped our new launch flow and customized Chrome frontend. And we continued our partnership with Hermes on debugging, making simplifications to Hermes CDP handling and shipping initial improvements, such as buffered console logs. So it was all systems go from here, we thought. But as we started planning new features, before this point, we had a realization. This bit really got us. Tooling was not only fragmented, but had for a while been fundamentally unreliable. Much of our debugger stack had fundamental design flaws, affecting reliability and correctness. Really, it was very broken, in whichever debugger front end you used. And it was unsustainable to keep adding more things on top of this. So our true, most important principle is reliability. Yeah. Tooling is only useful when it's dependable. And we know how much that matters to React developers. So despite our progress, we had to stop and rethink. To truly address reliability, we needed end-to-end ownership of the debugger. We've spent the last year rewriting React Native's debugging stack from the ground up. We've touched nearly every component, from Hermes to Metro on our dev server and the front end, but particularly on the device, adding new skills to our team in the process, to build reliability in at every level of the stack, to create a new debugger you can depend on. And we're calling it React Native DevTools. React Native DevTools is, at its core, a version of Chrome DevTools that ships as part of React Native, connected to this new debugging stack. It's been engineered to be reliable, familiar, cohesive, and simple, and is powered by an all-new backend. It comes with React DevTools built in. This means having the powerful React components and React profiler tools from web integrated into the same window. And compared to the standalone React DevTools app in previous React Native versions, this integrated experience now shares the same one-to-one CDP connection to communicate between the debugger and the device, leading to a consistent and web-aligned experience. All the core features from Chrome's console, memory, and sources panel work reliably because of the all-new backend. When you open DevTools, your app now understands the debugger is connected and suppresses warnings in Logbox. And in the console panel, you'll find beautifully rendered logs, as we've implemented the APIs enabling better object inspection and richer formatting. And when you connect DevTools, historic logs from when your app were launched are available on open, just like web. And vitally, we have breakpoints that consistently work. Who would have known? Which we'll dive more into later. You can launch React Native DevTools directly from your app or from the CLI, so long as you've got Chrome or Edge installed. There's no other setup or opt-in required. So that's React Native DevTools. Coming in React Native 76. By default. And with determined effort from our team, it supports both the new and old architectures. We've done this to support the widest range of React Native developers we can at launch. React Native DevTools becomes the single debugging experience for all apps using Hermes. We are releasing as stable, and there is no beta opt-in. This means that direct Hermes debugging via Chrome is removed, and we have no other Chrome DevTools front-end variants. We continue to support remote.js debugging, but this and other tools based on remote debugging don't use the new backend, and therefore have none of our reliability improvements or new features. We began rolling out React Native DevTools internally at Meta in April, and users are loving it. We've used this internal testing period to collect bug reports, telemetry, and feedback in order to observe improved reliability and quality, giving us the conviction to release as stable and open source. While a lot of what you can see and do in our new debugger is familiar, what's different about React Native DevTools is the stack. We started in a state where several core features did not work consistently and set ourselves the goal of fundamentally fixing these. We want a key takeaway today to be that this is now a debugger you can trust. This has been part of a close and coordinated effort with the Hermes team, who I want to give a specific shout out to. Together, we've made multiple debugger improvements at the Hermes level, as well as redefining where Hermes is integrated in our stack. So let's zoom in on a particular part of the stack, the debugger server. So what is a debugger? A debugger is an app connected to another app or web page at development time. In React Native, it's an app in two parts. A debugger front end, which you can interact with, connected to a debugger server or agent, which lives on the device. This configuration allows the app to ultimately ask questions about how the target app is running. Both the app runtime and debugger server also talk to the dev server for fetching code and source maps. As we've established, in React Native, this debugger session is a CDP session. Everything you see and do in the Chrome DevTools front end is powered by this protocol, organized into CDP domains. Groups of messages which roughly line up with the names of each debugger feature. This protocol is expressive and extendable. In order to work correctly, the front end needs the debugger server to behave exactly. The debugger server should also live for at least the lifetime of the debugger session in order to keep the context to handle these requests correctly. Up to now, this on-device debugger architecture was entirely handled by Hermes, plus some dev server hacks. This positioning of Hermes makes sense if we were temporarily debugging the JS runtime alone. However, in React Native, Hermes lives in the context of the app host. One of the key problems in our stack was that across an app reload, the instance of Hermes would be destroyed and recreated. Fundamentally, this required workarounds in our dev server to maintain a stable debugging session and to handle preserving state across reloads, which did not work reliably. So, we've built a new debugger server for React Native. It's written in C++ and is deeply integrated as part of React Native's core infra, enabling consistent cross-platform reuse. The React Native CDP server lives upstream from Hermes, owned by the React Native host. Together with a modernized packager connection, this solves a number of connection reliability and state persistence issues. Hermes now interfaces with the debugger as a runtime CDP agent with a better defined set of responsibilities. And we now support the concept of additional CDP agents. This solves an additional problem, enabling us to implement future features that talk to parts of the app but aren't Hermes. Together, our modern debugger server is ready for the next generation of browser-aligned debugging features built on top of CDP. This is one of the many parts of our stack that we made deliberate changes to as part of this re-architecture. This was a tremendous amount of work. And I want to give a shout out to Motti. So much of this re-architecture was due to him. Now, let's see how this translates into real-world improvements. Breakpoints are awesome, and are perhaps the most fundamental feature a debugging tool provides. You can register a breakpoint from the sources panel or in your source code, and your app will be paused whenever the code at your breakpoint is evaluated. This is really useful, as you can see all the program context around your code automatically, such as in-scope variables and the call stack. And with the breakpoint navigation controls, you can step through exactly how your code will execute, which is incredibly efficient. Early this year, we also implemented a stack frame ignore list in Metro, meaning by default, the call stack hides the node modules folder and framework code, the behavior of which can be toggled in the UI. But there were situations where setting breakpoints was flat out not reliable before. Here, we have a pause breakpoint in the old experience, and we trigger an app reload. The front end refreshes, and the breakpoint remains present in the UI. However, when we take the same action in the app, which is clicking this button, the breakpoint isn't fired. We have to go back to the sources panel and recreate our breakpoint. Also, here's the visual state of the application when paused. None of the JavaScript interactions are responding when we tap. However, you can still interact with the rendered scroll view. We thought this behavior was really unclear. Now, in React Native DevTools, when we reload the app, our breakpoint works. Yeah. And we render an in-app paused in debugger overlay, providing clear visual feedback, which responds to a tap to resume execution. Another scenario is when the device is disconnected or the app is closed. Here, in the old experience, we've just killed the app, but nothing in the debugger UI changed. It's in a zombie state. Now, we reopen the app, and again the UI is inert, but still displays our previously set breakpoint. And we can see that the breakpoint is again lost. In React Native DevTools, an app disconnect will raise a reconnect modal in the UI. We've also made reconnecting more reliable because of a new stable device identifier, meaning you can reconnect to the same device and app even after rebuilding. When we relaunch, we can see Reconnect DevTools. We can select Reconnect DevTools, and our safe breakpoint still works. So we've effectively fixed the core of our debugging infrastructure. And this means that third-party debugging tools, such as React Native IDE, should work with the same fixes when they're updated and made compatible with the next version of React Native. React DevTools has been reintegrated both in our front end and back end. Just like on web, React DevTools lets you inspect the React tree and highlight elements in app, highlight re-rendered elements, view and change props, and profile your React app. And we've put effort into getting details right. For instance, you're able to jump from components and function props straight to the sources panel. And this applies across the debugger. If there's any interaction visible in the UI, you can expect it to work. Before, React DevTools wasn't a well-integrated offering. We had this semi-reliable connection from the old debugging server to Chrome DevTools, and a separate standalone app for React DevTools. And this could only act as a singleton, attempting to establish a separate WebSocket connection. If you had more than one app connected, such as developing iOS and Android side by side, React DevTools could only connect to one of them. Now we have one tool, and we've sorted out the negotiation of a debug connection with each device. We now have React DevTools over CDP. This is fundamentally simpler and more aligned with web. Now you can independently inspect multiple devices side by side. And we display which app you're connected to at the top of each window. These changes mean that the standalone entry point for React DevTools is now deprecated and will not work with React Native from version 76. I'll also quickly highlight that we made several fixes on the native side to fix gaps with React DevTools on web. Notably, we've removed an inbuilt 200 millisecond delay that occurred during element highlighting, which now makes the components panel feel much more responsive. And finally, we also made improvements in our CDP support to add features and to better align with Chrome. This is coupled with other incremental improvements in Hermes. Improvements you'll notice are improved object inspection in console, as well as rich symbolicated stack traces, and the console utilities API, which powers the go-to-source behavior just seen. along with many, many fixes. And this work is ongoing. We care about React Native with Hermes one day supporting all of the protocol. So we published a website, links to our codebase, where you can see the real-time progress of our CDP coverage. So that's React Native DevTools, coming as stable in React Native 76. Our estimated date for the release is late October, and you can try it from next week with RC0. It's one debugger for React Native, enabled by default with zero config. It supports Hermes on both the new and old React Native architectures. It's an integrated experience, providing first-class, browser-aligned, and reliable debugging tools, built and maintained by the React team, where everything you see works. We're aligned with web, and our re-architected debugger stack provides a concrete platform for future releases. Everything in scope for browser DevTools is in scope for React Native. Looking to the future, we're excited to get going with new and refined capabilities. None of these features have specific dates, and items in early exploration don't yet have a roadmap. We see huge developer value at Meta from the performance panel, and it will be the next new feature we are targeting, followed by the network inspector. We're having an early look at loading third-party Chrome extensions to support additional dev tools that interact with JavaScript, such as popular state libraries, a clear request from users. And we also recognize the demand for integrated debugging in a text editor. We'd like to better support VS Code, which already includes built-in CDP support for JavaScript. But it also behaves slightly different to Chrome DevTools frontend, meaning we'll want to make alignments on both sides. We also see the potential for UI improvements, such as to better handle multiple devices. For these reasons, VS Code support in our new debugger stack is considered experimental. We won't guarantee it will work exactly the same way. We have so much we want to do, so expect other continual improvements along the way. We care so much about quality and about our community. We're putting up a dedicated feedback page in our discussions and proposals repo, with threads tracking the state of individual topics. We encourage you to not only be excited by today's takeaways, but to go and build your own trust in our debugging tools again by trying out React Native DevTools yourself. Thank you.